Hi everyone, this is Kerim Baran with Solar Academy. I am here today with Zhehan Yi of CPS. As you might know, CPS is the leader in CNI three-phase inverters in the American market, and Zhehan is responsible for Utility and ESS Product Solutions at CPS, the director of that division. And today we're going to talk about CPS's unique competitive position in the CNI market, their three-phase inverters and beyond. But before we do that, Zian, I'd like to talk a little bit about you, how you found yourself at this role at CPS, maybe a little bit about your schooling, your background, as far as you want to go. I know, like you are an implant in California, like myself. We both were born in Asia, or myself in Eurasia. And we ended up in California working in the solar tech sector. And so tell us a little bit about your background, and then we'll dive into CPS and its unique offerings.
Yeah, thanks, Kieran. Hi, everyone. My name is Zhehan. Well, that's a very good question, Kieran. I mean,
Yeah.
whereas growing up in overseas and working here, in the renewable sector.
Yeah.
Just a little bit background for myself. I actually went to school in Beijing in China. I grew up in China and finished college in Beijing before I come to US to pursue my PhD degree. So I have been
Were you double E, electrical engineering?
Yes, I have been in the
Yeah.
double E. Yeah, yeah,
Yeah.
electrical engineering ever since I joined college. So at that time we really don't call it double E, we call it power systems. So in China we differ, I guess, electronics from power system. Both of them are electrical engineering, but electronics is more consumer
Power
electronics
systems.
or low
Yeah.
power.
Yeah.
Power systems like more high power transmissions and
Yeah.
renewables and power electronics, of course.
Very cool. And then you came to the US for your master's degree and your PhD, or did you do the master's in China? And what was your area of focus when you did that?
Yeah, I came here for PhD, and in the middle, after I finish my master class, I can apply for a master degree, but it's the
Mhm.
same program and 5 years in total. So my area of focus after I graduated from college and joined I guess the PhD program has been solar and energy storage protection and control. Mostly, using power electronics techniques, or at that time what we call neural networks, or
Mhm.
very early stage of AI, to solve some of the protection issues in solar and in energy storage, as well as some optimization in the control of, those renewable resources in the grid.
And how did you end up? Yes, you've obviously had other roles, and you've been in this specific field for probably a decade plus. I'm assuming decade, maybe two. Tell us a little bit about that journey.
Yeah. So after I graduated, I actually joined a company in the Silicon Valley called Jarena, which is kind of like a research lab working on renewable technologies and
Mhm.
innovations for power systems and utility, mostly focused on renewables like solar and wind power, energy storage, microgrids. After that, I joined Delta Electronics
Yeah.
a couple of years before I joined CPS. Yeah, so yeah, it's I guess from my college, I've been working on renewables and the solar.
Yeah.
So yeah, it's for a while. Yeah.
Right. So let's talk a little bit about CPS and it as a major powerhouse in the power industry.
Yeah.
You guys are essentially an Asian company, but with a sizable presence here in the US. And maybe you can give us a little bit of a background on CPS as a company, and then we can dive into like the various different products that you want to highlight. Maybe it might be good to pull up some of the slides we were going over before as well. Oh,
Yeah. Cool. Yeah. Yeah.
yeah.
Yeah, CPS, or Chint Power System, actually is a subsidiary of a bigger company called Chint Group. So Chint Group is our parent company. It's a
Yeah.
public company in China, and it's I guess this focus area is broader than what we were doing here. Is more, electrifications, and, communications. And they have also a large business in actually power transformers
Mhm.
and also, PV modules. Like we have Astrology, our parent, our sister
Yeah.
company.
Yeah.
And also Norwork is also our sister company working on switch gears.
Hmm.
So Chint Power System is the subsidiary of Chint Group, focus on, I guess, power electronics, power supplies, work on inverters for PV, and we work on energy storage systems. Um,
Astrology, I remember that brand from early 2010s. Was it still part of Chint back then, I wonder, or did was that an acquisition for Chint Group? Uh, we used to sell some of Astrology panels in my old company as a distributor. Yeah,
yeah,
but
I believe it has been always under Chint. Yeah.
oh wow, impressive. Okay, great. Anyway, go back to you.
Yeah, so CPS America is I guess the US arm of Chin Power Systems. So it is very localized.
Hmm.
In the US we have a large thing over here focused on, servicing our customers and our products in the US.
Yeah,
And we work on a lot of, I guess, mostly in three-phase string for CNIs and now in utility
yeah.
projects. And we start to step in energy storage. Actually, we started energy storage back in even before the pandemic. We have installed, CNI storage, maybe more than 20 of them in the US. And we kind
Hmm.
of relaunched that, sector after, I guess, after the pandemic and in just in recent years. And
Yeah.
Qing Power System is not, um, I guess it's not new to any storage because overseas we have probably shipped or installed more than 2 gigawatt hours on any storage in
Mhm.
other countries. Yeah. So it's just for the US, we start to relaunch the energy storage.
Yeah, the core market, the core product in the U.S. market that you guys entered with, if I remember correctly, was the inverters, which you've probably sold many gigawatts. We were discussing the number. Is that around 10 gigawatts? Did you say of inverters deployed in the U.S. total to date?
Yes.
Yeah.
So, yeah, the total, I believe the total gigawatt that we deploy in the US right now is more than 10.
And that is mostly CNI and utility scale inverters.
Yeah, all
Yeah.
all three phase strings inverters. So we're very focused. We don't actually we had back in the time we have central inverters and we sell central inverters in other country, but in the US we only focus on three phase string.
Now might be a good time to dive into the product overview of the solutions you go to market with in the US market. And I know you had some slides that you'd like to share. So if you can pull them up, we can go through them.
Yeah, yeah. So this is just a kind of overview of CPS as PV utility PV platform. I guess a lot of our customers are very familiar with our utility, not utility, but our CNI products,
Mhm.
especially the 50, 60 kilowatt that you see nowadays. I guess all over the US on the carports. I see a lot of them, even over the highway.
Yeah.
Um,
I remember reading somewhere that you have had 20,000 such projects supported in the US, and that most of that is with those 50 to 60 kilowatt products, I'm assuming. Is that a fair assumption?
Yeah, we have more than 20,000 projects that we know of.
Yep.
There may be
That's
more in your customer or
yeah.
distributor.
Yeah.
They sell the inverter and installing somewhere that we may not know.
Mhm.
And yeah, it's about right. Yeah, more than 20,000 projects, and mostly in the early days are the I guess the CNIs inverters like the
Yep.
50, 60, 36, 25.
Yep.
Those 280 projects.
And obviously now you are going up market into bigger project sizes, bigger CNI projects and utility scale projects. So this is the utility PV platform we're looking at.
Yeah.
Cool.
Also, kind of a history of the utility project in the US.
Mhm.
Mostly in the past and even nowadays, it's dominated by central inverters. But we're
Yep.
seeing a lot more projects asking for string inverters,
Yep.
um, given the benefit that it can offer, and also, the uptime, especially for the string inverters, because replacing string inverter is easy. Just
Yeah.
swap.
Yeah. And the whole system doesn't go down when it's down, right?
Yeah, you're limited to that, maybe 350 kilowatt instead of the entire block, like 4 megawatt, right? So
Yeah, exactly.
you can
Kind of
swap
like the
easily,
micro inverter effect in Resi happening at utility scale.
similar to that,
Yeah.
assumption. But the other benefit is the serviceability, right? You don't have to, I guess, replace the entire block.
Yeah.
Instead, you can just swap the inverter down, which we're talking about maybe 2 hour, 3 hour labor.
Mm-hmm.
And in most of the case, in large utility projects, customer or EPC or the O&M company, they would stock some of the spare units on site.
Mm-hmm.
So they can use the spare unit to replace the failed one and send the failed one back afterwards. So they can get
Right.
this thing up first instead of,
Yeah.
having to wait, run the RMA and
Right.
inspection everything, which can take weeks or months, depends on the lead time of the parts, right? We're
Yeah.
talking about central. So
That
a lot of
makes
benefit,
sense.
yeah. So we're seeing a lot of utility asking for strings inverters as well. And
Yeah.
that's why, we are powering that field, and we have good product to support projects like those.
How new is that trend of moving from central inverters to more string inverters at utility scale solar projects? Is that a thing of the last 2, 3 years, or more like 4 or 5 years, or 1 year? Uh, what we
Yeah.
should say? Is that a
Well, that that depends on another very tricky question.
which
What
is?
how do you define utility project?
Yeah,
Right.
yeah. Is it one
We've
megawatt or
seen
5 megawatt or 10? Yeah,
we've seen a lot of community solar, right?
right.
Those ground mounted, but still consider DG or CNI. But those projects are like probably around 5 megawatts,
Yeah,
which those projects has been using string inverter. A long time ago, yeah, for a long time. But if we're really talking about 100 megawatts, 200 megawatts projects, I think is maybe in the past decade or
yeah,
even closer, maybe 5 years, you know.
yeah, yeah. Got it.
Mm.
Makes sense.
And very interestingly, in Asian countries or in the Europe countries, a lot of those utility projects are dominated by string already. So US is
Yeah.
kind of a I guess, unique place where most of the utility projects are still using central inverters.
Interesting. Got it.
Yeah. Yeah.
Okay.
Yeah. So maybe let me
Yeah.
dive into the
Yeah.
products just a little bit,
Yeah.
back now before that. So this is an overview for our utility PV platform. So on the top, you see we have these three inverters,
Mhm.
275, 350 kW. Both of those are 800 volt AC, and we do have a new inverter, what we call a 250 kW 600 volts. This is a
Mhm.
600 volt. So we do offer
Mhm.
both, in the US. And we have a whole series of accessories, what we call a total solution with the inverters. Nowadays, we're seeing, customers prefer a one-stop shopping, for the solution. So we provide both the inverters as well as the, I guess, low voltage switch gear, including the breaker box, switch
Mhm.
box, um, which all of these are 800 volts. And we also even offer, medium voltage transformers um, in the US. So it's a whole solution that we can provide, from DC to AC, even up to the medium voltage,
Yeah.
34.5
So
kV.
is it now becoming more common to see this solution set in 100 megawatt plus size utility scale projects?
Yes,
In
I would say
US?
so. Yeah.
Yeah.
Yep.
Got it. Got it.
Especially, when in the I guess projects are using central, it's mostly like a central skid, right? Like a 20 feet container or like a 20 feet skid that you drop to the side. With a string inverter is very similar. So you also have a central skid, but it's just a transformer. The inverter itself is mostly distributed across the field.
Yeah.
Um,
Yeah.
serving as like a conversion and also a combiner,
Yeah.
converting DC to AC and run an AC home run instead of DC home run. We also have what we call ACPLC kits, which can provide communication for some larger projects. Instead of running, RS-45 daisy train, which can be a very long run in utility projects, customer can utilize our ACPLC kits. This use the AC cables to communicate to the inverter and or bridge the inverter to the SCADA. So the communication, wire saving there is also a good, consideration for a lot of installers. We even provide a cluster mount. If you look at this one here, it's a three inverters plus a breaker box, kind of like an 875 layout for
Yeah.
utility projects. We're seeing this being installed along the driveway for the projects at the end of the checker tables for easier serviceability. All of these are facing one direction, so truck pull in and then can service inverters and the breakers, in case it's needed.
In my recent conversation with Anton, we talked about CPS's approach to designing solutions for customers' ease, and this is a good example of that. This cluster mount, yeah.
Yeah, and followed by that is just example of our utility, power block or a building block. This is a 4.2 megawatt example, which showing in 15 275 inverters, 5 breaker boxes, 5 switch boxes, and a 4.2 medium phase voltage transformer skid. So we provide the entire solution and provide certification for different parts of it. So the system is tested and fully verified by CPS.
This is probably a good block for community solar projects. It's probably ideal for that size, is what I'm assuming. But is it being used in other applications or use cases?
Yeah, we have 100 project with 100 megawatt and above using this system. Yeah,
25 times over. Yeah.
Yeah, and in fact for community solar, I've seen a lot of 5 megawatts block, but for 5 megawatt they usually don't use like a single 5 megawatt skid. They use 2 of the 2.5 instead. So, excuse me. So we also have a different size of medium voltage transformer, and like we offer 2.8. So 2 of the 2.8 will give you 5.6, which gives you can use it as a 5 megawatt and with the additional kVA overhead or MVA overhead in case of 0.95 power factor or volt control is required by the utility. Then you can utilize the overhead. And the rest of the inverters and breaker boxes, switch boxes, the number you can just decrease that down, right? So it's very flexible. It's all modular design. So either it's a 4.2 or it's a 2.8. It can be the same design, just a different numbers of it. With the 350, it's very similar. So we unify the design for our solution. So later, if we have other inverters, we can do similar things. And one thing to bring up here is the 800 volt. Why we do the 800 volt breaker boxes and switch boxes? It's in around 2020 when we start to work on 800 volt PV inverters, we see a lot of customer asking where they can find the 800 volt breakers or switch or fuses to work with our inverters, and we're seeing the limitation in that. And usually, what we are found is there was a long lead time for those items, and which slowed down the inverters projects as well, because when a customer buy your inverter, they need to know where to buy the rest of them to get a project up. So we decided, okay, we can provide those. We can, work on a total solution for you. And why not? Because we're the system, provider. We know our inverter the best, or even, better for, the switch gear companies, right? So, and we're good at this. So we provide a total solution from inverters, breaker box, switch box to medium voltage transformer.
Makes sense. One question: Can customers buy these direct from you guys, or do you go to market via distributors like Green Tech Renewables and others?
For utility, we only do direct purchasing. So it's all through CPS.
Okay, for these larger products, it's all direct.
350, I guess is one of the highest power string inverter now globally. And it's a very high power density inverter. Dimension of the inverter, it's very similar to the 275, but the power is increased significantly, right? From 275 to 350. So it features 15 MPPTs. So each, 350 have 15 MPPTs in there, which is a lot. Central inverter, right? A central inverter, for example, like a 4.4 skid usually have maybe 4 MPPTs. If you have, let's say, 15 MPPT in even a smaller 350, if we're talking about 4.2 megawatt, how many of them? Like 12 times 15 MPPTs available.
Yeah.
That's going to give you a lot of flexibility in generation. And especially if your projects having, the PV arrays or trackers facing different direction because of the terrain, or for example, if it's a hilly area, you can utilize the MPPTs to give you more production. So
Yeah.
that gives a lot of more flexibility in generation in projects.
Right. More optimization, almost like what happens in a microinverter again, but at a whole system scale.
The design is fully compatible with nowadays a 210 millimeter bifacial PV modules, which can go up to 700 watts per module, right? It has a really, I guess, wide compatibility with different modules. And we have up to, 40 amp per MPPT max operating power and 48 kilowatt per MPPT max operating power. Really
Which
huge.
which bifacial PV modules are compatible?
So most of the bifacial PV module will be compatible. Here I'm listing like the 210 millimeters because that's one of the highest power module now available in the market. But most of the bifacial PV module, for example, those 500 megawatts, 500 watts or 600 watts up to 700 watts, most of them are compatible with our inverter. And we do have, PID mitigation function built in the inverter. So if project asking for that, some of the modules asking for a PID mitigation function to be able to, get their warranty, our inverter does, provide that function. And we have what we call the reactive power at night, or Q at night function, which allows the inverter to give reactive power even with the sunlight. So at nighttime, if the utility asking for, I guess, a reactive power, the inverter can provide that and, make extra money out of that.
Remind me again, what does PID stand for? Or how does that?
Potential induced degradation.
Yeah. So, and the benefit of that feature is
to reduce that degradation or to eliminate the degradation. So the module power can, I guess, have more power over a long time because the degradation induced by that is limited by the inverter. So the inverter will be able to, to make sure that the site would have more power compared to, if you're using inverter without that function.
it kind of helps provide a healthier power wavelength or I don't know if it's the frequency but eliminate to result in less degradation of the panels.
It's basically the degradation happen, right? Because of the nature of the PV module would induce or would have that, especially thin film would have that degradation. And the way there are multiple ways to mitigate that or recover that. Our inverter have integrate, one of the, I guess, most popular way to essentially by lifting the, I guess, the PV negative and PV positive of the module side, the DC side. And in that way, the PV module, I wouldn't say lasts longer, but we have less loss due to that degradation.
Thank you for that.
And just some quick comparisons of our inverters to the market offering. So if you look at our 275 and 350, it's an all-rounded design, we have a lot of different, features and functions compared to our competitors, right? Even if you're looking at this derating temperature, we offer a higher derating temperature than most of our competitors in the markets. If we just take this as example. Our 350 still as a 350 inverter, at a temperature of 40, even 45. And in the US, most of the utility projects or large utility projects are built in the desert or in the Southwest, where the temperature can go pretty high in the summer.
When you say 40, 45, that's Celsius. So that's over 100, 104 Fahrenheit, right? Yeah.
Yeah, like 100 or 110.
110. Yeah. And so you guys essentially lose almost nothing level of heat.
Yeah, unless it's more than 45 degree C.
Yeah.
So yeah, but it's compared to the market offer, right? If you're talking about like 10%, even 10% more generation at a 40 or 45 degrees C, you are generating more than 10% of the power. And also that's not only related to power cost, right? That means that you can, size your system without inverter with less inverter.
All right.
Right. For example, if you're using a 350 with us and 350 with others, if we can power, more than 10% compared to the other one, that means you can use 10% less equipment. And that's 10% less labor probably, right?
Yeah.
And later the O&M costs related to it.
With the others, you would have to oversize the panels and then with racks and wires, everything goes with that and labor.
Yeah, it's a whole system. It's not only the inverter saving.
That adds up 10% more investment.
Yeah, and that's a lot for a utility project because the size
Sure.
is more sizable for it.
And that changes your ROI from 10% to 12% or 11%. That's a big difference. Yeah.
Yep. And for the 250, 600 volt, this is our new inverter. We have it available ever since this year. And it's a little bit different design. It's a single stage. So this is a single MPPT inverter at 600 volts. It's probably the largest power at 600 volts. In terms of string inverter now available in the US. And I'm showing here two very interesting pictures. We can put this 250, 600 volt inverter on a integrated skid like this, together with a switchboard and a medium voltage transformer. So this is kind of like a virtual central design, which can combine the benefit of string and in a central layout. So for some project, the customer would prefer this way of layout because some of the project they are using, let's say chambas or like a BOA harness, even the conventional DC combiner, to allow the EPC to pull the larger cable from the PV array directly to the skid instead of having to run multiple or large number of string cables. So save a lot. Maybe in the cabling, and also easier for installation because it's from the inverter to the transformer, it's all pre-wired and pre-installed. So this just
So you get it, and that's it. Yeah. What's the size is that
you need a DC and the AC, and that's it.
40-foot kind of?
This is about 37. This example they're using here. Yeah. It's a 3 megawatt block. Yeah. We have a life size of this example in our Dallas headquarters. So we show this in our innovation week this year. Got a lot of good feedback on that and good interest in this.
Really simple ideas implemented well makes a huge difference from a customer satisfaction and ease of use point of view. And sounds like you guys are doing a good job at that.
Yeah, I guess the most important is customer feedback, right? We hear we've been doing project for years, and we hear customers' voice. Why didn't you guys do this? And also, we have our own team, keeping us up in the market, for the technology that we are selling or that we're working on, to make sure that we are competitive enough over time. So we have product strategy team, looking at really 5-year, 10-year out to see what's going on and what we can do. So this is just a start. We have, more exciting projects and products coming, and our ESS platform here comes to, energy storage. Really, you can't separate PV from energy storage because nowadays a lot of projects have both of them co-located, even from, residential, right? You have Now you have residential PV and energy storage, CNI, and utility. So a lot of different use case and applications, for both of them.
Do you guys go down to the resi level as well in the US market?
We don't, but we do have single phase products, which typically are being used in small CNI buildings. So we have the 5 MWh power block power together with a 2 or 2.4 string inverter skid. So this is a pair product, and we have CNI too. This is a old generation 125, 279 or 250, 558. And the new generation is what we call a Gonzo energy storage. It's an all-in-one design. So we have 62.5 or 125 kilowatt or 261 kilowatt hours. So we have, I guess, 2 hour and 4 hour options for it.
And then the single phase size is what generally?
We have from 7.6 to 12 kilowatts for hybrid outlets. And we offer the battery as well. So the battery is stackable. A rack can give you like a 20 kilowatt hour.
So you guys have basically like approximately a quarter megawatt hour, half a megawatt hour, and then 4 and 5 megawatt hour blocks. So
covering different projects, right? From small business buildings and small CNI to larger CNI, and even larger utility. So we have all this product to cover different size of projects. So this utility ESS, we have actually CPS was one of the earliest to make a 5 megawatt hour battery in a 20-feet container, using a 314 ampere hour battery cells. So for utility battery cell, in the past it was mostly dominated by 280 ampere hour, and 314 is kind of the new norm in these products, and we were the first to integrate that in our products. This one we provide both the battery and the PCS. The PCS is again is a skid with inverters on top of it, and also a mini voltage transformer included, and we have switch gear underneath in the compartments over here. So it's an all-rounded design, I guess, for utility projects, and even some of the larger CNIs are designing their project with us. For example, large buildings or stadiums, those can usually utilize containerized batteries as well. So it's all designed by CPS. Again, we have 2 hour and 4 hour options, very modular design, similar to our string inverters. The PCS skid over here, if you look at the design, I don't have a larger picture, but on the top here, there are actually 12 string inverters instead of an entire like central inverter. So 12, they each one is connected to one rack into the battery container. So each container can run independently. If one of this is failed, the others can still run. And replacement will be pretty simple. You can just take one module out and then just slide a new one in and connect the cables, and that's it. So the service of it is pretty simple, and provide more uptime. Especially batteries, the uptime means a lot for projects. And we have 9540 for all different options here. And the CNI one, this is the Gonzo. This is 261 kilowatt hour, but we do offer 2 different options. It's using the same enclosure, but the PCS size is different. We have 62.5 as well as 125 kilowatt. So this gives you from 2 hour to 4 hour options, which is mostly common in, I guess, in the CNI buildings or applications. It's all in one design, so it's pretty small. If you compare to our last option, it's a PCS cabinet plus a battery cabinet, but this one is just one cabinet. So reduce the footprint by more than 50% for installation. And if a system or a project needs more of them, we can even parallel them in operations.
So does that cabinet have what does it have in it? The inverter, the battery, and the comm device all in one. So in a 55 by 39 inch. Wow. So if you needed like a 500 megawatt kilowatt hour storage,
You just need two of them, two of this 125, right? It gives you
yeah.
500.
And by the way, the 62 and the 125 are the same size cabinets,
Semi enclosure. So
same enclosure. Okay. So you need two of those to have 500 kilowatt hours of battery. Wow.
correct, correct.
That is
So
impressive.
yeah, that's a lot. The energy density is very high in here.
Can you
Um,
put that into the garage of a multifamily building? Just curious. Is that
depends
allowed?
on the depends on the local fire department's code,
Uh,
right? Yeah, it
and
may or
can
may not be allowed.
can you put it outside and it would be protected from rain and everything else?
Yeah, this is outdoor rated
Outdoor
cabin
rated.
CODs. Yeah, yeah.
Wow.
Most of the CNI is installed outside by the building.
Yeah.
So if you have multiple of them, you can do them side by
I mean,
side.
that's essentially 10 Tesla power walls in a, 4 by 3 foot cabinet in terms of the bottom area, surface area. That is impressive, right?
Uh, yeah, if you're talking about I guess the power or like
Yeah.
the
The-
energy,
oh no, it's
like
actually more than that.
210. Yeah,
It's
210.
20. It's 20
20.
Tesla
Yeah,
power out.
yeah.
20 20 power walls. And the area it takes is probably, I don't know, I would say 3 times more than a Tesla power wall, but you have 20, you know,
But
in
it's
terms
different. It's different
it's
application.
higher. Yeah,
Yeah,
yeah, totally.
CNI. Yeah, yeah,
Right. But
yeah.
one area as we discussed that I'm kind of close to is the multifamily segment of CNI. I think storage is going to be really important because a lot of buildings have parking spots, EVs,
Mm,
dozens of apartment units, and then they put a single array for the community out to flow all the electrons and store them between batteries and EVs and units and optimize all of that. And that's a whole other challenge in a multi-tenant environment. And a couple of these types of batteries in or near the garage, which communicates with the EV electrons that are stored in the EV and used at the tenants on demand, um, will be something in the next 5-10 years. I have no doubt.
yeah.
And being able to store something separately outside of the EVs will be important too. And this does it in a very efficient manner.
Actually, that's a very good application, and we're seeing a lot of more demands over that application in the past. I guess
Hmm.
just really recent years, maybe starting last year, last 2 years. So PV plus EV storage, it's a very good application because with the EV getting more popular, and EV chargers being installed, right? EV chargers can take a lot of power and and very high power, right, in a short period of time that usually require the building to upgrade its transformer, right? If you
Right.
want kind of install more EV charger,
Yeah.
your building is typically, unless it's a new building, right? Typically the the service utilities transformer is not sufficient enough for you to support that many EV,
Right.
taking limitation on that. And even we're seeing, car dealership, they are selling EVs. They have to install the EV chargers, but the utility, I guess the meter and as well as the the transformer is not sufficient. If they want to go to, upgrade that transformer, get a permit, from the utility and get it done, get it upgraded, it's gonna take a long time.
Right.
But one way is you can install a battery, install PV, so you can have your energy localized for those EV chargers, right? For example, you can use a battery store excess power from the PV, and then if you have a lot of EVs getting plugged into the charger, and I guess
You can wire the chargers directly to the battery, like a DC to DC fast
um,
charger kind of situation.
well, you can, but we are doing as AC couple. which I guess is more convenient for installation and
Yep.
upgrades. Yeah,
Right.
and reaching fitting. So you can
But you
use
can,
it as the energy the
yeah,
same. Yeah.
and you can still wire the EV charger directly to the box without needing to upgrade the transformer,
Right,
basically.
right. So you can I guess defer the needs for upgrading the transformer and still have the EV chargers installed
Right.
and get rid of demand charge, right? Otherwise,
Yeah.
if you have the EV getting up, I guess the peak power will be pretty high and definitely give you a huge bill in the demand charge, especially for CNI.
Yeah.
So the CNI storage can really play a good role in that, I would say, with the
Right.
EV train. Yeah.
So, what are some of the most common CNI project application types that you're seeing in the market these days in
Well,
2025,
yeah, the
2024,
EV.
2023? Like, is the trend trending one direct? Like, I'm assuming data centers and AI, like,
Yeah.
is a big uptick in demand. But yeah, tell us a little bit about like what you're seeing in the lay of the land out there in the market.
Yeah, I think it's growing, I guess, everywhere, not really into one direction, but the areas that you were talking about, the AI and the data center is one of them.
Hmm.
Especially in Texas, we're seeing a lot of project like that, and California because of net metering,
Hmm.
the new program, the NEM3, also in stimulating a lot of projects and customers to install battery for CNI buildings.
Factories,
Yeah.
distribution centers, things like that.
Yeah, and we are also seeing a lot of more, I guess, increasing demand for 4-hour duration battery. Well, in the past, it's mostly 2 hours. I
Mhm.
guess it's also related to the backup power requirements in case if the grid goes out or
Yeah.
there's power outage. You can utilize the battery provide power, kind of like a microgrid application, especially for critical buildings, right? Critical loads like hospitals, data center. Those usually require a uninterrupted power.
Yeah.
So yeah, we're seeing a lot of different projects like that as well. And of course, the EV plus storage, we see car dealership installing batteries. And in fact, we've installed one of them last year in California for car dealership. So this is the new products, and we have liquid cooling and air cooling combined in this.
Mhm.
Liquid cooling for the battery packs and then air cooling for the PCS. So it's a
Mhm.
mixed cooling technology. And again, it's modular design, pretty simple. 9540, you have 9540 certified, so it's already to go. And this has been listed in CEC, and we also work in HECO. So it's all ready to go. This is my last slide. So just want to bring this up a little bit.
Yeah.
Talking about why CNI ESS, and I know we talked about that just a couple of
Yeah.
minutes ago already, but this is a visual. It's a kind of typical low curve for a CNI building.
Hmm.
Where in the afternoon, once the AC kicks in, right, you have the power going up and then going down in the evening when people get off work.
Yeah. It's
Um,
like a typical office building or
it
something
is.
like that.
Yeah,
Yeah.
you get to pick office building or school. So
Mhm.
so typically the utility charge you for energy as well as the demand
Demand
charge.
charge.
Yeah,
Yeah.
if you have high peak, then demand charge can be pretty high,
Right.
even
Yeah.
50%, 70% of the bill
Yeah.
sometimes.
Yeah.
So with solar, you can kind of oversize the solar, and then once the solar kicks in the day, the
Mhm.
energy kind of go down, the total power kind of go down, right? Because of the solar. And you
Yeah.
you kind of also, if you size the system up, big enough, then you probably can sell some of the solar energy back to the utility.
Yeah.
Uh,
In the NEM 1 and NEM 2 era, you would probably oversize that so that that green area under the line would be even
Cheaper.
bigger.
Yeah.
But now with NEM 3, because there's not as much value to that overproduction because utility is not buying it at retail rates anymore, you probably size it more like this today. That makes sense. Yeah.
Well, with storage, you can still size it up, right? You can
Yeah. You can
get a
still
storage.
arbitrage that. Yeah, exactly. But even if you sized it like this, what I guess your point is that that demand charge is lower, but it's maybe 10% lower than what it was before because That
Well, the demand source
demand.
is maybe still there because the peak
Yeah.
is not
Yeah.
eliminated, and
Right.
the solar goes down. It's not detachable, right? Depends on the sun.
Sure.
So if you got a cloudy day, then you
Yeah.
still get a demand charge. And again, like you said, like you may be wasting the power sending to the grid because it's so cheap.
Yeah.
And even in summer, right, in August in California, is you're talking about maybe very, very cheap power
Mhm.
selling if you're, sending power back to the grid.
Yeah.
With the storage, you can kind of reshape the whole curve, right? You can store the excess power from
Mm-hmm.
the PV to the
Yeah.
storage and
Right.
discharge the storage later when the peak is still high. So you can kind of
Mhm.
eliminate the peak um,
Yeah.
demand in your utility bill, and that saves you a lot.
So your peak demand is never higher than what it was in the early hours of your morning time.
Right,
Yes.
you can manage to do that if you have your inverter, if you size your solar and the energy storage properly, you can manage to
Yeah.
do that. Yeah,
I'm assuming there's a whole ecosystem of consultants and designers and engineers that are designing these solutions because
yeah,
it's getting more and more complicated. It's not as simple as just using the good old helioscope and aurora anymore. Now there's like a couple of layers more of sophistication, which Energy Toolbase and other products like that probably help model in the sales process of these projects. And
exactly.
yeah,
And different, I guess, different places they have different time of use program and
we have
again
different
different rating.
rates, different
Yeah,
different rules, different demand charges, different mixes of
yeah,
cost. Yeah,
yeah. It's so
does it
very
optimize?
customized.
It's like in the early part of the 20th century, there used to be a title called VP of Energy in corporations, Vice
Okay.
President of Energy. It seems like we need that again because this
Yeah.
is not so straightforward. Yeah.
Because right now, I guess it's more complicated because of different buildings also have different load profile. So you want to optimize the installation based on that profile as well, right? So this is a typical one where you have power in the day, but some of the building, like some manufacturing site, you may have power consumption at night as well,
Yeah.
right? So it's all different, and also some agriculture side, so different.
Yeah.
Yeah.
Yeah. So y- one of the unique things about CPS, if I remember correctly, is the fact that you don't just sell these hardware solution sets, but you also have the engineering and design and pre-sales, post-sales support team that acts as a consultant along with all that. Is that would that be a correct statement?
We are still a equipment provider only.
Yep.
Our service is based on our product only. So we service our own product. If
Right.
if this is being sold as a part of the solution to a site to a project, we are only responsible for our product because obviously
Right.
other product we're not expert in that,
Other.
and
Right.
they have their own supplier to service that part.
Right.
But we do have our service team working in the US. Our service department is in Dallas. We have a large service team taking care of different technical issues coming from customers.
And you do have engineering team that you extend into your services as well. Was that?
Yeah, we have service engineering, we have application engineering and product team here in the US.
Well, as we near the end of our conversation, maybe some last words on how to get in touch with you guys, how you go to market, how what are some resources available to prospects and customers. You can talk a little bit about that.
Yeah, well, we're always available in the US, and you can find all the contacts on our website. Um, we have hotlines, you know, engineering's answering hotlines in the working hours. And if there's any questions related to service technologies or any interest in, our new products, you can always reach out to us. We have also, sales hotline website.
What is that Flex O&M system that I remember from a previous conversation? Can you say a few words about that as well?
Yeah, yeah. So Flex O&M is it's our service portal. So
Mhm.
what it really is a so for the inverters, it communicates with the internet through a gateway, and we would call it Flex Gateway. So Flex Gateway enables the inverter to get on the internet, and customers can utilize that Flex Gateway to to access their system. Like we can give access to customer for the portal, so they can see how the inverters are performing. That's from customer side, but the other side is the service side. So in case, for example, if there is a unit having technical issue, we can get the authorization from customer to access that unit and to see if there's anything that we can do remotely. For example, sometimes it's just a power cycle or like a firmware upgrade can fix the issue. That way we can
Yeah.
do remotely instead of having to roll a truck to the field to take a look at that. Sometimes these projects are really far away in the middle of nowhere, so you can save a lot, from that perspective.
Well, Zion, thank you so much for this great overview of CPS America's solutions for the US market and deep dive into the products, uh, understanding of your capabilities, service capabilities, talking about your service center in Texas, 20,000 live 9 gigawatts of live assets across the US. Thank you for sharing all this information with Solar Academy.
Yeah. Thank you for having me. Thanks, Kerr.